All right, in this video, we're going to go through some of the Chapter 1 practice test questions, starting here with number 5. So in number 5, the question says, which of these represents the average rate of change of this function on the interval from 1 to 3? And the key to this problem is remembering that average rate of change is just the slope of the line that would connect the 2 points. And what 2 points do we mean? Well, we mean the 2 points where these are the x's, x is 1, x is 3, and the y's are whatever the y values of this function are. So you're going to have some graph, right? You've got some cubic function here. It's going to look something like this. And then you've got 2 points on that graph, and I'm totally just making this up. But assuming that was a straight line, not squiggly, what would be the slope of that line? And so for slope, of course, it's just y2 minus y1 over x2 minus x1. Now the x2 and the x1, that's easy. That's the points they gave me. So that's 3 minus 1. But I need to figure out those y values. And just like we say over here, those y values are just the y values of the function. So where did I get this point? Well, it's the y value of the function when x is 1. It's the y value of the function when x is 3. So how do I find those values? Well, I plug 3 into the function. And I plug 1 into the function. And that's this one. All right. Number 6. Which of the following statements about f at x equals 2 and x equals negative 1 is true? Well, I can see in all my answer choices here that we're talking about being discontinuous. Whether we are continuous at a point, or have a vertical asymptote, or a removable discontinuity, or a jump discontinuity, what's happening at each of these values. And so the first thing I remember is that I can only have a jump discontinuity in a piecewise function. This function is not piecewise. So it's not going to have a jump discontinuity, so anything that talks about a jump discontinuity is out. Now, the question then is, okay, do we have a vertical asymptote, a removable discontinuity, or are we just continuous? And the values that they're asking about are x equals negative 1 and x equals 2. But just like first thing I think about is that we can only have a jump if the function is piecewise. Well, we can only have these other types of discontinuities if the function is undefined at that value. So I need to figure out where is this undefined. And since there's no roots and no logarithms, the only thing that's going to make this undefined is a 0 in the denominator. So I need to factor and figure out, okay, exactly what is my domain. If I factor the denominator, I'll get x minus 2, x plus 1. I'll also factor the numerator. First factor out an x, and then you'll get x minus 3, x plus 1. And so certainly this function is going to be undefined at both 2 and negative 1. So it's going to have either a vertical asymptote or a hole, either an infinite discontinuity or a removable discontinuity, because the function is undefined there. So that really eliminates for me all of the options, and I can just say, all right, well, it's the last one. But since we're here to explain and make sure we can do this on the test, let's make sure we're clear on why it is, in fact, a vertical asymptote at 2 and a removable discontinuity at negative 1. Because if I plug in negative 1, the denominator is going to be 0, and so is the numerator. That makes it a removable discontinuity. I am literally able to factor it out and remove that issue. Whereas for the negative 2, if I plug in, for the positive 2, if I plug in 2, the denominator will in fact be 0, but the numerator will not. So it will be an infinite discontinuity or a vertical asymptote. All right, moving on. Let's make this a little bigger as well. Okay, so they've given us this parent function, the exponential function 2 to the x, and they're asking us what are the values of a, b, c, and d to perform these transformations. So I just look at them individually and think about how to do each of these things. A horizontal shift, that's performed by adding or subtracting to x inside the function. So that's c. If we're going left, well, left seems like it should be negative, but it's the opposite, so it should be c is positive 2. Vertically compressed by a factor of 3. Well, vertical, that means it's to the y, so it should be outside the function. And that's then either a or d. And since it's a compression or a stretch, that's how much I'm multiplying the y by. So in this case, I'm vertically compressing by a factor of 3, which means don't multiply by 3, but divide by 3, or in other words, multiply by 1/3. And then shifted down 2 units. Again, that's vertical, so it should be outside the function. I'm just adding a -2 or subtracting a 2 to my function there. Sneaky one here. Well, they didn't say anything about a horizontal stretch or compression about b. So should I leave it blank? Should I make it 0? What should I do? Well, if I don't want to stretch, well then what should I multiply by? Well, I should multiply by 1. If I multiply by 0, well then you've just changed this whole thing to be 0. Now it's a constant. You've gotten rid of your variable there. So we certainly don't want that. All right, so we have this graph, and the question says, which of these different transformations would allow our graph to include the point 2, 2? And the sneaky thing about this question is that, as it says, there's going to be potentially more than one correct answer. So I can see several ways that I could get to this point 2, 2. One option would be to simply, and so one way to think about this problem is just to go through each of these and see if it would work. You can also, of course, look at the picture, see which ones make sense to you, and then try to find those in the options below. So I'm going to look at each of these and kind of go through them one by one. Okay, so a negative multiplied by the outside, by the y's, that's going to flip it over the x-axis, because it's right now, whatever the sign of y is, it's going to change that. And if I notice, currently the graph goes through 2, -2. Multiply that by a -1 on the y, and you're going to get to +2. So that first one does in fact work. If I add 2 to the y's, though, that's just going to shift everything up 2, which would take this point and move it to 0, not all the way to 2. So no, that one's out. This next one says subtract 2 from the y's. Well, certainly that's not going to work. We're just going to go down, so that one's out. Now, inside the function, add 2, so that's going to affect it horizontally, and that's going to be the opposite. So this is actually going to move everything left 2. So that's going to move this point that way. I don't want that. Reflecting over the x-axis, change the sign on all the, or sorry, reflecting over the y-axis, change the sign on all the x's. It's actually not going to do anything at all. My graph is even. The left side and the right side are the same already. And then shift it. Oops, this one was supposed to be no. I don't know why I circled that. Sorry. And then the last one, inside the function, that's a horizontal transformation. does the opposite. It looks like you're subtracting 2 from the x's. You're actually going to add 2 to the x's. And that would shift it over and give us what we want. All right, I'm going to go ahead and stop this one, and we'll pick up with another video for the next few questions.